Right, guys. So we're talking about solving a triangle. Now, do you know what solving a triangle means? No. No. Okay.
No.
Okay, so we're solving a triangle means we're finding the unknown angles, we're finding the unknown sides. You already have a couple of methods for solving certain triangles. What have you already got in your locker? Pythagoras' theorem enables you to do what?
Find the hypotenuse or the sides.
Find the sides of a right angle triangle. So Pythagoras' theorem is limited to right angle triangles and sides. What else do you have there?
Trigonometry.
Trigonometry.
For finding angles and sides.
Angles and sides this time, SOHCAHTOA. Limited also to right angle triangles. So at the moment, the only thing we can do with a triangle that's not right angled is find the area, right? Which is very important. But we'd also like to be able to find the sides and angles of a non-right angle triangle, and we can. Right? There are two rules that you will need to know. Okay. There are two rules that you will need to know. I think they are available to you on the front cover of your exam paper, in the little formula sheet that you get, but it would benefit you to remember them. Now, the one we're going to look at first is sine rule. Now, all I'm going to do is I'm going to tell you what it is, and then we're going to use it. If you want to go off yourself and figure out how it's derived, up to you. You can do that. It's a good thing to go through, but we're just going to state sine rule and cosine rule and how and when to use it. So, just to let you know as well, sine rule and cosine rule are not limited to non-right angle triangles. They also work on right angle triangles. They're just a more sort of complicated version of trigonometry. So trigonometry is the simplified version of sine rule, cosine rule. So you wouldn't bother, that's all. But they do work. Now, first thing to say is the labelling of a triangle matters. Right? Often you'll see, just like in that last question you did, you've got angles A, B and C with capital letters, and you've got sides also marked A, B and C. And it's important that they go together. So, angle A is opposite side A. Okay? B opposite B, C opposite C. That's important. You can't have A and A next to it. It doesn't work that way. Often they will change the letters in an exam to make sure you fully understand, to P, Q and R, or J, K and L. Same thing applies. If you have a J for an angle, you have a small j for the side. Okay? Right. So based on this triangle then, the sine rule deals with the relationship between an angle and its side. So if I take sine of the angle, okay, I take sine of the angle, and I divide it by the side opposite it, okay, I get a number. I get an amount. Okay? Obviously that amount is determined by the angle and the side and so on. But I will get a value. That value will be the same value if I did sine of B over B. It will also be the same if I do sine of C over C. So actually we have three parts to the sine rule, but you will see we only actually ever need or can use two of them. Alright? Now, I'll say it now, sine rule can be written the other way up. So it doesn't give the same value, but if I write A over sine A, that will be equal to B over sine B and C over sine C. So just to show that works using numbers, okay? So if we do 2 over 3 equals what?
4 over 6.
4 over 6 equals another one?
8 over 12.
8 over 12. Okay. Well, if I were to write that as 3 over 2 equals 6 over 4 equals 12 over 8, am I correct?
Yeah.
Okay. So I'm not saying that 2/3 is the same as 3 over 2. I'm not saying that at all. But I am saying that 2/3 is the same as 4 over 6 and 3 over 2 is the same as 6 over 4. So in that way, because sine rule follows those fraction rules, I can write them either way up. And that helps us because if I want to find an unknown angle, I would use this one. If I want to find an unknown side, I would use it this way around. Any ideas why? Yeah.
Because then you can just multiply each side by the bottom.
Yeah.
So having to rearrange
You don't really want, you can use it either way round to find either. Hello, you with us?
Yeah.
Oh, good. Right, hello, you're just staring into space down under the table. And, oh, you're looking at my computer screen rather than board. Okay, fair enough. You don't have to swap it around. It just eliminates a step of rearrangement and solving. That's all. It's easier and nicer to have the unknown value as the numerator of a fraction rather than as the denominator. That's all. That's all it is. Okay. So now that is sine rule. There's nothing more to it. Now we've just got to figure out how to use it. Okay. So let's have a look. So if you look in your book, so we're on page 585, but I'm going to go through the example, okay, on page 586. So let's have a look. So you can write all this out as well, it doesn't hurt. Okay, so there's an important aspect to this. I need you, well, actually no, I don't need it. You need you to be able to look at an exam question and determine when to use sine rule. Now, it's quite obvious in an exam question when you're expecting to use sine rule and cosine rule, because you'll see a triangle appear that is not right angles. Okay, so there's your examination tip. You see a diagram that is not, that is a triangle and is not a right angle triangle, you should automatically think, oh, sine rule or cosine rule. Right. So let's say we've got to that stage. The idea is to decide, well, when do I use sine rule and when do I use cosine rule? In an exam question, you normally have to use both. Part A will be one, part B will be the other one. Right? So, let's have a look. Sine rule. So, sine rule will be, I've got an angle. We've got to find BC. BC is this side. What am I going to label it as? A. So, that's A. So, I'm going to have the unknown on the top divided by sine of 113 equals, well, what else do I know? 18 over 41. We don't need the third one. Now, using sine rule is completely dependent on one thing. Two things, sorry. Two things. What must you know to use sine rule? No, you can do it with the right angle triangle. You can. If you look at what we've just written, you have to know. There's two things we have to know to be able to use it. Yeah.
two angles on the side.
Potentially, if you're trying to find a side. If you're trying to find an angle, No. Ricky?
The unknown should be the numerator.
Well, no. Again, it can be. I could write that up the other way up and still work it out.
You need to know which angle is goes to the side.
Okay, so that's one thing. It's not just the angle. In this case, I have to know the angle opposite the side I want to know. If I wanted to find an angle, I would have to know the side opposite the angle. So you have to know the opposite thing to what you're trying to find. Have to. Okay? So in this case, I have to know the angle that's opposite. If I don't know the angle opposite, I either have to try and work that out first. It might just be a case of 3 angles make 180. Or I can't use sine rule. There's another thing I have to have, which is a complete pair. If I know one from each 3 of the things, I can't do anything about it, and you'll see that. Alright? So, what do I do now if I'm trying to work out A then? Very simple.
You solve B10 divided by 7.
How do I do that? So,
It's 27.4.
yeah, but what do I do? Just tell me from this part, what do I do?
Well, the thing I did was solve the right equation to get 27.4, and then
Oh, okay.
I
Right. If you try and do that, you might have to round a little bit, and you might get an inaccurate answer. Remember, we talked about inaccuracies. Ishan, what would you just tell me how to do?
You could do it to put the sine around 13.
I don't like the putting it. It's divided by sine of 113, so we have to
Times it.
times both sides by the sine of 113. Okay, that eliminates it from that side, and I'm left with A equals 18 times the sine of 113 all over sine of 41. Okay, now it's better to do it that way for them though, because I now can put it all into my calculator in one go and not round until the very end. Okay, so on your calculator you will put in 18 times sine of 113. See, that will be in brackets on your calculator. Okay, and you will divide by sine of 41. Now it shouldn't be a problem, but if you want extra security, you can put your brackets around there to show all of that is divided by just that. Okay, it shouldn't be an issue. You should do it fine. What answer did you get, Svetiga?
25.3.
25.3. What? Meters. Okay. And just check. Another exam tip. Always go back and draw it on the diagram. Why?
So you know for the next question.
That's one part, yeah. You might need to use it again. Okay. You might need to use it for the next part. That is perfectly valid reason. But also, it enables me to look at it in context of the entire question. Does it look reasonable? Okay, does it look reasonable? Alright. Now, just to show you, I'm going to do another example, but not from the sine rule. Just to show you when you wouldn't be using sine rule. Alright. So, just quickly, I've got this example. So we've got 10 meters, 12 meters. Right. We won't actually have to do any calculating here, so it'll be very quick. A, B, C. If I want to find BC again, so I'm going to call it A. If I try and write sine rule, so A over sine of 38 equals B, which is 12 over, don't know it, sine of B, that's right. C is 10 over sine of C. Now, I've got information in all 3 parts, but the problem with it here is what?
You don't have a complete pair.
You don't have a complete pair, and the problem with that is
You can't solve it.
you can't solve anything. Yeah, right. There's no rearrangement because I've got whatever two I choose. I've got two unknowns, and you have to have. You've got two unknowns. We then need simultaneous equations. So sine rule will not work in this case, and that leads us on eventually to cosine rule. But we're not going to do that just yet. All right. Any questions on that? No.